Alright, welcome back. This is the thrilling conclusion to the pre-lab for the Friedel-Crafts acylation reaction, and it involves, now that we've got our mixture of product and all the byproducts, how are we going to get our product in hand? So this is the workup. So what you're going to do is you are going to take your reaction mixture and you're going to pour that in a SEP funnel, and then you're going to add a little bit more dichloromethane, and then you will do the extraction, which one of the things you need to do is remember to shake. You're going to have to shake it to mix these layers all together, right? You want to mix them all together. And you need to remember to open the stopcock, preferably while it is pointing up, not down, so you don't lose all your product, but open your stopcock so that you vent your reaction. So now the million-dollar question is, where is your product? Is it in the bottom layer, the dichloromethane layer, or is it in the top layer, the aqueous layer? I'll give you a second to think about that. And while you're thinking, there's a picture of your product. Okay, so hopefully after some thought, you said, hey, this is organic, so I bet it's in the dichloromethane or organic layer. And so now I've got my product. Some of it was in the aqueous layer, but now I have extracted a lot of it into the organic layer. So there is my organic layer, and I'm going to drain the organic layer out into this Erlenmeyer flask. Okay, so now I have my first dichloromethane extract in this Erlenmeyer flask. So I had my aqueous layer left in the, my aqueous layer was left there in the separatory funnel. And so now what I want to do is I'm going to add another aliquot of dichloromethane. So it's a fresh aliquot of dichloromethane. I'm going to go through the extraction process, mixing up the layers again, and then what I'm going to do is I'm going to take that first extract and then I'm going to drain the second extract into it so that I have a flask with my combined extracts from my aqueous layer. So then I'm going to take that original aqueous layer and I'm going to put it to the side. Okay, I'm going to put it to the side, and because I don't want to throw anything away until I have my product in hand, remember? So hopefully at this point, this aqueous layer, I've extracted everything out of it that I need, and now what I need to do is I'm going to take these combined organic layers and I'm going to pour them into the empty separatory funnel. And since now when I've done that, what we're going to do is we're going to clean up that organic layer a little bit. It's got dichloromethane, it's got our product in it, and it may also have some water in it, and it's also going to have some HCl in it as well. So what I want to do is I'm going to do some things with the separatory funnel in order to get out a little bit of the water and all of the HCl. And this process is called washing, because what I'm doing is I have my bottom layer, I have my dichloromethane here, and it's got. So the first thing we're going to do is we're going to add this aqueous layer. The first aqueous layer is going to be sodium bicarbonate. And the purpose of the sodium bicarbonate is it's going to react with the HCl, and you're going to end up with sodium chloride and water and carbon dioxide gas, and that's why venting is key. I would recommend that when you're doing this that you invert the separatory funnel and open the vent and swirl it gently a few times to release some carbon dioxide. Don't even try to invert the funnel or to shake it back and forth. I would say just shake it while it's upside down and keep the stopcock open, and that will help you to get rid of a lot of CO2. Then you can invert it a few times, but every time you invert it, you've got to be sure that you vent it or you're going to be wearing your product. Okay, so now what you want to do is we're going to drain out the dichloromethane layer, And then you're also going to drain out the aqueous layer, and once again you can just put that to the side. You could actually combine it with your original aqueous layer that you're saving, and it'll probably bubble up a lot since there's probably a whole lot of HCl in that original aqueous layer. Then what you're going to do is you're going to take your flask and you're going to bring it up here and you're going to pour that dichloromethane layer back into the separatory funnel. Then the next aqueous thing that you're going to add to it is a sodium chloride solution. It's a saturated sodium chloride solution. It's also called brine. And you add that, and that's going to be your aqueous layer here. And once again, you're going to shake it up and extract it. No exciting stuff is going to happen when that happens, but what it does do is the sodium chloride can be sort of an initial drying agent. Though any water that's dissolved in the dichloromethane, that is going to tend to go into the brine layer. So once you finish that extraction, then once again, you'll have your dichloromethane solution, and you're going to drain it into a Erlenmeyer flask. So now we've got our dichloromethane and product solution here. The next thing we're going to do is we're going to add some magnesium sulfate to that in order to take out the rest of the water. And remember, you add the magnesium sulfate and swirl the reaction. It should look kind of like a snow globe. You'll see the dichloromethane layer might be kind of cloudy, and then it'll get clear. And that's one of the ways that you know that you've added enough magnesium sulfate. And then you want to gravity filter that solution into a tared, that means pre-weighed, round bottom flask, and then we'll put it on the rotovap, and you'll rotovap off the dichloromethane and get your product. Okay, so then the last step in this process is we have to analyze our product, especially since we're going to use it in our next reaction. We want to make sure that we know that we've made what we think we've made. So that to answer that first question. So spectroscopy is going to tell us a proton NMR. You can do that in deuterochloroform solvent. And one of the nice things is that, let's see, the R group is going to look pretty much exactly the same as it did in your original spectrum. And so will, or the aromatic peaks, remember that's between 7 and 8 parts per million, and that's going to look pretty similar. Or actually, it might look a little bit different, but it's going to be in the same range. You'll just hopefully integrate for 4 hydrogens instead of 5 hydrogens. And then you'll also be able to see this CH3 group, and since the hydrogens that are attached to this carbon are close to a carbonyl group, this is usually at around 2 parts per million, and I'll let you think about if there are any adjacent hydrogens to split those hydrogens on the methyl group, or perhaps it will just be a singlet. Another important analytical technique is going to be infrared spectroscopy, because this compound is going to have a CO, a carbonyl group. And remember that carbonyl group appears at around 1700 reciprocal centimeters, and there would not have been any of that in your starting material. Once you've isolated your product, you can calculate your percent yield. You're also going to use that mass. Remember that mass is the mass of your starting material for the next step in the reaction. So you'll need that information in order to do the pre-lab for the next reaction. So what we're going to do is you'll have a week or so to do all this, actually almost 2 weeks to do all this product analysis, because next week, the week of 2/29, we're going to do integrated, and then the week of 3/7, right before break, is when we'll do part 2 of this, and that's when we'll do the Grignard reaction. Alright, so I know that was a lot of stuff to do, and it was probably a little bit stressful, and I just want you to remember that you should maybe stretch before lab so that you're fully relaxed, and that will keep you from making a whole lot of mistakes. Alright, see you in lab.